Satya Singeetham spent 17 years at FIS, rebuilding their core banking platform and building a brand new CI/CD from scratch. He has learned a lot of things and made a lot of things happen, and most of them were almost deemed impossible. I'm Suresh Mathew, and this is One Idea. If you like the show, please share it with an engineer, like and subscribe. Welcome to the show, Satya.
Thanks for having me, Suresh.
Perfect. So let's start with the FIS story first, right? When you joined, you had a monolith that I'm thinking close to 20 teams were working on. And if you were to make a change, you ship the whole monolith out, right? And you fixed it. And how did you do it? How long did it take? What was the whole story?
This is a small story that I would like to share, before anything. The why and how and all those things, right? Because it's very important for the story itself. Because back in 2005, 2004 timeframe, we started this journey of trying to take an existing core bank solution, which is based and built on COBOL, the mainframes, right? And that was a very good core itself. It is running almost like 300 banks in the Scandinavian data center in Denmark. Now, what we did was we wanted something in the modern core, because obviously people wanted modern core. People don't want to be stuck to monoliths like mainframe systems. So we wrote a Java tool back in the day, and it converted it to a Java code. If you look at the Java code, you'll understand that the naming conventions that are used in the code that was generated almost represents how COBOL program looks like. The little example is SRV. It's most of the files end with SRV because that's a kind of COBOL language, programming language used to be like that. So when we did that, what we essentially got was a huge monolith of an entire core banking solution. A core banking solution, if you will, comes with a customer component, an organization component, a product definition component, loans, a mortgage platform, deposits, checkings, and so on and so forth. Now, when we convert it, it's a big one big monolith. Now, if you want to implement such a huge monolith into a bank, even though if the bank wanted just one component or one product, like let's say term deposit, they have to take this entire suite of products that we are coming with, because it's a monolith. You cannot. So we did try that. I was actually working in Istanbul, working with the bank technology team to implement term deposits for the bank. And I spent 4 years in the bank working with them. At the end of the day, I can call the project was both successful and not successful, because the CTO changed. He had other ideas in terms of what he wants to do with the money. And he decided not to pursue this project anymore. So he shelved it. And we came back. And the lessons that we learned from that is, can we survive with this monolith? So what we did, that's when the story started, is we just retained the data model, which was built on, the data model was built on IBM's, it's called FSDM, Financial Services Data Model. So we retained that because it's a very strong financial services data model. It defines every structure in a way that it can be portable, understandable, pretty easy. So we kept that. And then we started building what we call today is called the modern banking platform at FIS. So what essentially we did was we built componentized world of core banking solution. So we separated out the customer component, the product definition, the organization piece, and then we built something called as an account processing engine, where all kinds of account types can be created in one place. And then on top of it, we started building this business offerings, which is deposits, commercial deposits, savings, and then loans, and so on and so forth. Now, with this comes obviously a lot of challenges. Now we're talking about a monolith converting into microservices or hybrid. I'm not a big fan of microservices, by the way. And then it comes to the challenge of how are these components going to communicate with each other? That's when the events-driven architecture got into existence. And that's one of the projects that I was leading back in FIS. And then one of the challenging projects was the CI/CD platform itself. Because now we are talking about components that are split, and imagine a number of teams working on a customer component and deposit component and that's the account processing engine and the deposit solutions. There are many, many teams. To name a few, anywhere between, at any given point in time, like 8 to 15 teams working on small size teams, 7 to 8 engineers. And yet it's a huge number of people trying to do something. So we had to build the CI/CD platform. But even before that, there were a lot of other things that we had to do, which is actually modernizing the core, building the Docker images that follow a certain rhythm of how we were trying to build these components. So we started with that, and that came with its own problems and set of problems because we were running on IBM WebSphere, which is old, and then we had to convert it to more open source platforms like JBoss, and for that you had to do a lot of changes and in the architecture itself, and then start a journey of building the Docker images. And then we chose OpenShift platform, and then we started the journey of writing the CI/CD platform.
There are a few interesting problems for us to dig deep into. We can either go into the core platform, that's one option, or we can go into the messaging distributed system side, or we can go to the CI/CD. Let's go into the CI/CD side. So I think that's where people see a lot of coordination needed, especially with this new AI in play. People know easily how to develop. They know how to maintain. Now, the critical thing is going to be the release, right? So how do we make sure that's a coordinated? So let's go double click on CI/CD. Now, there is no monolith. There's enough distribution. 15 teams coordinating. How do they all coordinate and release?
That's a very good question and a very difficult one at that. My message is and was and always be simple is with the advent of AI and whatnot. If you do not build a delivery system which is like a controlled structure, then it's noise and chaos everywhere, AI or not. So AI can be a force multiplier. You can expect your teams to write code faster, but if you cannot build an environment where release is a repeatable and understandable process, then whatever we have done, the change that you're trying to control is a waste of time and money. Now, AI can do a lot of things. People will think that just your code is productivity is improving 70%, 70%, but that's not the problem. Anybody's, with all these tools that we have, but the problem comes what happens when and after you push the code. That's when a real CI/CD problem and release management comes into play. We had a pretty good structure in place in terms of it was not a social contract. Our CI/CD platform was more of a engineering outcome or engineering product that we built. We treated the whole CI/CD itself as a product and not as a tool. And that's when everything changes in terms of the requirements, in terms of how you want to build it, or how you want to maintain it. So every product comes with a discipline. So it's almost like a release train. If you make it, you make it. If you don't make it, you lose the train. You have to wait for the next one. So that's the discipline, essentially we tried to bring in. A lot of issues initially. People were missing the trains. But then once the teams understood the evidence that we are trying to collect from all this process, the quality gates that we are trying to implement in terms of the code that's going to get merged, and then all the deployments, automated deployments and whatnot. So, and this is all automated. By the click of a button on the moment the developer says, hey, I just PR merged my code, the entire our Groovy script that we wrote, the CI/CD platform, it just goes Jenkins build happens, and then it goes and runs through the SonarQube analysis of static analysis of the code. Then we also do security vulnerability checks using Fortify kind of things, and then Black Duck for security vulnerabilities, right? And so on. So there are so many integrations that we did. And then it builds a Docker image, and then it actually creates and puts it into a team-specific OpenShift server that is specifically built for them. It's almost like an ephemeral environment, on-demand environment, puts it there. And once it is there, everything is tested, all the integration tests, everything get through with the kind of release cadence or the release agreements that we had. Okay, keep one particular component, you're supposed to give us this version. It's there, yes, and we run all the tests, it passes through, and everything becomes like an orchestrated engineering feat rather than some sort of a chaos control or debugging session with the release management. That's what we have done. It sounds pretty, I simplified it, but it was a lot of effort and discussions.
Was there no option to really pick one existing CI/CD platform available?
We never had one in terms of the CI/CD, because if you look at it, I'm talking about the time frame of 2014, 15. That time it was not, CI/CD was just a concept, and DevOps was just kind of, people are trying with that word called DevOps, right? Development and operations coming together. So we were actually the pioneers in FIS. FIS is a huge company, 60,000 plus people. And modern banking platform, what we built, actually pioneered this area of DevOps and actually Docker build Docker images and OpenShift and even the events-driven architecture. We built a framework called Courier Framework. We built it broker agnostic. It can work with any broker, whether it's Kafka or whether it's RabbitMQ or IBM MQ series or ActiveMQ. Now it's called Artemis. Essentially, we were really trying to pioneer and find new ways of efficiency in engineering practices.
Nice. And for the events driven system, this platform was consumed always. Sorry, all these platforms were always consumed through your central platform or the broker agnostic thing, Courier.
The Courier framework. The way we built this was, again, we didn't want to introduce APIs for events-driven architecture. So the way we built it is almost, imagine it's like your SDK. Courier framework is almost like an SDK. So it's basically you take it, you wrap it up with your asset that you're trying to build. Once it is inside, the configuration is all automatic. It comes with the natural configuration with XML application YAML files and all that. You just have to define the topic names that you want, or who are your consumers and all that. And that's it. It doesn't really matter what is your broker, because every configuration on the OpenShift takes care of one entry. It's Kafka or whether it's ActiveMQ and so on and so forth. So that's how this Courier Frame. So Courier Frame essentially, it can sit in all the components, and the messages that are produced. The way it works is when a transaction happens in the core itself, the transaction integrity includes a commit of the message to our Courier platform, essentially the message broker. Only when this is successful, the entire transaction is successful, which means that we are going to make sure that the data is integral to the system it's producing. So the moment the event is driven or event is generated, there are downstream systems which need that information to go and process what they were trying to do, and also to keep the system in sync between these various components.
And they acknowledge it back?
Yeah. For example, if you take Kafka or ActiveMQ, it just takes it, acknowledges it, and they go and process whatever they want. But all the time, we don't necessarily mean that there is an underlying process that is actually taking your message and trying to do something. But it's more like, I've done this activity is complete. You go and take and do whatever you need to do with the other component. Like, for example, I updated an address, and then the deposits component needs the address because it generates the statements, and statements are sent to the customer. If customer is updating the address in customer component, the deposit system needs to know it. Previously, it was one monolith, remember? Now, because of this, we split it. This sits in a different table, different system, and this deposit is in a different system. So this events-driven makes sure that it is always in sync.
Now, let's pulling you back to the CI/CD world, right? So what is the cost of a bad release? Assume there is a bad release. What happens?
Bad release in a regulatory or a regulated environment like banking software or fintech software, it's not just a bug. It is reconciliation problems if something goes wrong. Customer onboarding is impacted. Biggest one, the trust of the banking clients is lost. And the blast radius is operational in nature. It's not a bug that you're trying to triage. It is the operations and all the people involved in trying to understand the blast radius of what we created as a part of a bad release. And bad release can mean anything. You don't have proper rollback scripts, and that's it. Your contracts are not matching. Imagine a bank which is running its software, and the next day morning they need to open their shutters. The previous night you chose a time frame to go and update their software, and bad release happened. The next day morning they probably cannot open their bank. They cannot open their tellers. They cannot open business. So it is not a simple bug. It is essentially almost a trust-breaking situation that can occur. So that's the cost of a bad release.
That is not fun.
I've been in the firefights, many in my life in such instances when things went wrong. So I can, first-hand experience, I can tell you it's not a good place to be in.
Now, coming back to the code release, right? The first thing you do, of course, is to make sure you can validate what is coming in new, right? And what was the process there? Did you use a tool? How did you make sure that the check-ins, the code is validated?
So the moment any developer checks in their code and a PR is, let's say, merged. So before the merge happens, the code that is committed by the developer, individual developer, runs through a series of CI/CD steps that we've introduced. The first one is obviously the build, making sure that the compilation errors are not there. Then comes the quality gates, which is your, like I said earlier, all your SonarQubes and everything.
Yes.
So once that passes, making sure that you have not introduced a null pointer exception or an array out of bound exception kind of things. And then once all that goes through,
So you have unit tests in that process.
unit tests and everything. This is a series of steps that you go. And after that, the Docker image is built in a certain fashion, in a repeatable fashion. And it's not, then we use the same image and so on and so forth. So, and then finally, it can get deployed. So these are the set of steps that are, again, these are all contracts, like structure. It is non-negotiable. It is not, like I said earlier, it's not a social contract. It is not personality dependent on a particular lead who is saying, oh, you cannot negotiate these terms. The evidence is there. This is how you pass these gates. These are not optional. These are all mandatory items.
And this includes integration test as well.
Integration tests and everything.
So when you design those integration tests, especially for continuous deployment, I'm thinking the efficiency of the test is also a parameter, because you may have to build this continuously, which means it cannot be expensive. How do you design such a test?
So we had a pretty large quality organization, obviously, and every time we develop something new, the integration tests are always modified, right? And then we have a set of regression test suite that we run on a daily basis in the night, which is like, it takes its own time. We're not really running it on the mainstream servers and all that. But coming to your point, the integration tests, and when somebody likes it or not, it's a must-have. And the issue that comes with the integration test is the time it takes to essentially complete, and in a given period, you don't want your release to continuously go on for forever and all that, right?
Once you have your code ready, validated, I'm thinking integration test done, everything good. The next thing is to make sure that you don't break others. It's deployable and the whole block stays intact. How do you make that happen?
In the olden days, the way it was, we had our set of automated functional test scripts that we used to run after the fact. That's one way to look at it. And off late, recently, obviously with AI, what we are able to do that is, using AI, you're able to go and create this functional tests, which removes essentially your manual labor, QAs trying to test after a fact. Like, okay, I've done this. This is all deployed properly. Now I need to make sure that all these 100 test cases are passing. That's how, recent times that we have done, which is using AI scripts. But back in the day, yes, we used to have manual testing, random testing, and this is, I'm talking about in 2017, 2016.
How big was that team?
The modern banking platform team was anywhere between 700 to 1,000 people put together. It's a very huge organization within FIS, of course.
Now, the code is validated. Everybody, the whole integration test is passing. Even the product-wide tests are passing. The next thing that at least in my eBay days, we had something called train, and there's something called train conducting. This was probably back in 2007, 8. I think we jammed on this bandwagon pretty early. So we probably were the first ones to try it, and we got it done pretty quickly. The problem that I faced there was, there were a lot of people trying to release, and you had a train conducting team, and they were always at not a great spot. And as you said, rough conversations in between. And now there could be changes that are, if not done sequentially, could create problems, right? There could be a change, and that change may be dependent on 10 other changes right before it. And when something is missed, it becomes very complex. How do you handle that? What was your experience with the whole release sequencing?
When I was in the enterprise architecture, I was running enterprise architecture team in India, and our team was responsible for a lot of these things that, you put a good name to it. It's a train conducting, but we are essentially running the pipeline. We were the ones who maintained the pipeline when something breaks and whatnot. Our problem was more at the data level to a large extent, because like I said, you are defining and building your component against a certain contract, and against a certain requirement, and against a certain technical design. The technical design comes with its own core base data, we call it. that this is a configuration data that is essential. Now, we need to keep track of all sorts of various data, base data scripts that are required for it to run successfully. Otherwise, the feature itself will not work because it looks for a certain base data item. And if it's not propagated properly in the environment that we are trying to test, all your tests will fail. So we had that problem. And obviously, our contract was in such a way that at least our engineering release and development principle was T-2 support. All our API contracts have to be T-2. Otherwise, it's a no-go.
What is T-2, by the way? Sorry.
So T-2 is you have to make sure that your contracts are supported for 2 versions before what you're releasing today. So because there are a lot of these clients who do not want to upgrade, and that's another problem we can talk another day, is why a lot of clients, bank clients, they don't want to go and upgrade to the latest and greatest versions of the software. At one point in time, we were supporting almost like 10 or 15 versions back because a certain bank, which is not so tech savvy, let's put it that way, they're not interested. This is good for us. But now on the vendor side, on the as a developer or the platform owner, now we have to maintain these 14 releases. So imagine that you actually go and make a code fix in the latest version. It has to go deep into all the different releases. So yeah, it comes with its own set of problems. But to answer your question, yes, we had the dependency problems, and what we used was Flyway is one way that we actually solved the base data problem. Other than that, coding wise, in terms of the software, as long as the versions that we are negotiating the match, that's good. Another thing about how we did in a modern banking platform was, like I said, it's a configuration driven. So most of the times, whatever happens, the code itself does not break, but the functionality won't work because it looks for a certain base data configuration item, which is supposed to come with your release of that particular version.
Does feature flag by any chance help you here?
Not in a feature flags. I really don't think actually work in the traditional huge banking software. If you're talking about a simple application, a social media or something like that, feature flags might help. And personally never thought that actually feature flag is a good idea in financial services.
It is a bit risky, right? So especially with the compliance and standards that you have to follow, might be a bit risky, especially if it's not considered right from the design inception, makes it harder.
That's right.
Now, from the cultural standpoint, right? So again, this is something that you are introducing, brand new to an org that's big, and they have their own org sentiments. How did you manage that?
Like I said, I was one of those guys who were running the enterprise architecture team. And one of the things I was trying to do was teach the importance of what we are trying to do here, rather than not saying that you got to do this. Yes, we had rules set up that this is how it should be. Like I had instances that I remember developers, because of the friendships, used to come and ask me, Satya, can you just pass or remove this particular SonarQube test that's failing for us? We have a release.
Just remove it, just disable it.
I did, because I understand the importance of process or efficiency over processes. I do understand that, but that should not become a norm. Every time something is not working for you or it's taking too much time, you come and negotiate with me. So, for example, a lot of people were not really understanding why the SonarQube was in place. So I had to really educate them what's going on. Like I should show them like live sessions. Like if you practice this enough, it becomes your muscle memory to write a code in a way that Sonar expects you to pass. So that's how education was one of the most important. I used to take lessons on Maven, trying to teach people what actually a POM file means and what each and every tag in that POM file actually does. A lot of people didn't even know what they were doing, where they were just doing it, because the system was working. So that was one way, education. And sometimes, yeah, I had to use force. This is what it is. You got to do it. And a lot of times, the biggest problem was everybody had their own, like you said, organization. I own this particular land. Do not come and try to step into our things. We'll do when it comes, when the time comes. But again, the importance has to be understood. If your software is vulnerable because you've not passed the quality gates, then when the auditor comes and looks at your system, you may not pass, you may not go into production. So these are all some of the things that you need to keep in mind.
I have a trick that I use. I call it Wi-Fi. What is in it for me, right? So the thing is, as long as they see that it is helping them, which is essentially the case, people generally align. Of course, there will be conversations where things are not aligned, but that Wi-Fi framework at least helped me a lot. Now, coming to the outcome side. Now, one good thing about CI/CD in my mind is you are now a lot more agile than you were before,
Yes.
right? Things go a lot fast, lightning fast. And with that, there could be a risk of a little more agility than expected there. For example, releases could go in quickly without a lot of consensus. How did you manage that agility versus stability versus the requirements?
It was pretty simple for us. We had a set of every 2 weeks releases. This is it, like 2 weeks. And if something's urgent, yes, there's always, we had a maintenance team running. And if a certain bug, which is required by a specific or a production defect had come, we had other process to go and put that fix into place into existing running software. We had process for that as well. But release wise, yes, you can be agile, but you get a chance every 2 weeks. And that's how we managed it. And there was no discussion about, oh, can I go 2 days every release? No, it was because if you don't have that kind of a discipline in a team organization of that size, things are not going to work.
To set in stone. And from an acceptance, what was your success criteria for this whole project, CI/CD project? When do you call it successful? Or what was your plan?
The day when these people stopped pinging me or my team members, said, hey, this is stuck, or can you please pass us through the security gate? Our security gates are not passing, so on. So yeah, the success criteria was pretty simple. We were able to understand the release process in a very matured way. There were no surprises. There was no release debugging that we were doing on a daily basis, which was past the case. And you see, we also had our dashboard where we could see how many builds are failing and whatnot. So we had this control of releases going quickly and without any incident or things breaking, things falling out of place. So success criteria was, are we sticking to the date of release that we said that we're going to release, and how many times we missed or how many times we did not. So that was very simple for us.
And Satya, you are operating this whole engine in a regulated industry, a regulated environment. I'm sure that that creates its own sets of problems for you. If you were to name like top two, top three of the constraints that you were building this whole thing with, what would they be?
Compliance is definitely one of the biggest in the banking industry or any financial service industry. One of the things is obviously the vulnerabilities aspect from a technical perspective, because if you talk about a recently Anthropic has released something called as Glasswing or Wing Glass or whatever, right? They are talking about this vulnerabilities that AI can now detect on age-old operating systems, which otherwise people didn't have the intelligence or the time or the money to spend on or expertise. But now with AI, they're able to now figure out the vulnerabilities of the operating systems. And if it falls in the wrong hands, you can imagine what all things can happen. So why I'm saying that is because as in a regulated industry like banking and financial services, compliance and in the security or the vulnerabilities was the biggest three things I would say we have to be careful about. And that comes through in a lot of way through CI/CD maturity, because there are a lot of these tools, like I said, Black Duck can help you identify the softwares or the software products that you are using, libraries that you're using to construct your product, and the vulnerabilities it flags, and it tells you that you got to upgrade. These are the simple things, but if you don't do them, because imagine you're writing like serious code and somebody comes and tells you that, hey, you got to go and update your log4j version from 2.1 to 2.7. Why? Because in 2.1, we found a vulnerability which can do some SQL injection through your logs. As an engineer, you'll say, get out of here. I'm not interested to do that. Because that's a little bit of a labor and manual work. Now, here is where I would say AI can help these kind of things, where my principle is AI should be working inside the control system that you built. And that's when you'll call your delivery as a successful delivery management that you create, or the release management process. Now, that's where I would like to use AI, for example, where you find the vulnerabilities and how quickly can AI go and fix those problems without an engineer's time or a release manager's time.
Yeah. So I always ask all my guests, right? AI is here. And if you had AI back then, right? Back when you rebuilt your platform and build a new, brand new CI/CD platform, how would it change the whole equation?
So AI, in my opinion, in the financial services industry, especially regulated industries and compliance is a key. I would define AI as somebody who can help me triage things for documentation, for telling me the best possible refactoring ways. But I will never let AI approve or do any transactions and whatnot. In terms of the product, you cannot let AI post something on behalf of, instead of a human approval process. But what AI could do, perhaps, which I would have definitely built back then, is which will cost or save millions and millions of dollars, is take, for example, the ACH disputes process. You make a transaction, you call the bank and say, I did not do it. Now, the onus is on the bank to prove you otherwise. Otherwise, you have to pay the money back to the customer. And there is a game, a lot of fraudsters, a lot of people who just do something and say that it's not me. And a lot of times banks have to write it off instead of spending a lot of money and time investigating an ACH transaction, for example. But if AI was there back then, I would have built an agent which could go and look at the trace of what happened and when happened and collect the IP addresses and prove that,
Collect
hey,
all the evidence and then
evidence and send it over to, hey, you know what, this is what has happened. This is your device. You logged in. This is your signature, like this is your digital footprint, right? Imagine if we had to do all these things today or back then without the assistance of AI. Another example is reconciliation. My system is out of balance. My general ledger is not balancing today. I can ask AI to investigate what's going on. It's essentially looking at data, but it's not going and posting anything. So I'm safe and regulators are happy. And I would have built the modern banking platform way faster than what it took for us to build back then if AI was there.
thank you so much, Satya, for coming and talking to us about your journey. And again, that journey is extremely important, and it's not easy to see a person who has experienced this level of detail right from the ground, who can also see it from a leadership standpoint. So thank you so much for all the wisdom that you shared.
The pleasure is mine. I love the conversation. Was pretty interesting, the kind of ideas that we shared here. I hope I am able to help few fellow leaders and engineers to maybe learn a bit from me or from this conversation. Yeah, but I learned quite a lot from conversations with you. So it was pretty interesting. Thank you very much for having me as a guest.
It was one. My pleasure. Thanks.